So, let's take a look at some news. A lot of interesting news stories today on Pulse Security Weekly. I was just recording that podcast, and they had a lot of cool stuff. Here's one, how to open a safe. My friend Caitlin hacked into a safe. They lost the combination. She just hacked into it. And this guy has a nice write-up on how to do it, which is really very nice. There's this thing called the Sentry Safe and Master Lock Company, and what he found was you take the safe and you take it apart and you have a keypad, and then there's pins here that send a signal in there. So all you have to do is put a sensor on these pins. The logic is here. When you get, what I got from taking a quick look at this, when you complete it, it sends an unlock signal in, so you can just send the unlock signal in. Which is, the same thing was true of the first generation of encrypted USB sticks. You would plug it in and a thing would pop up saying put in the password to unlock the stick, and that's fine. But if you reverse engineered that app, the app would just check the password and then it would send the decrypt signal, so you could just send the decrypt signal from the app. This is a fairly common flaw that you'll find, so that was a cute one. And I couldn't believe this. I thought it sounded like a joke. You can put Edge on Linux. And I don't know why you would do that, but you can do it. And Paul Asadorian, who is a real security expert, famous guy, he says he uses Edge all the time on Linux. He likes it. So I didn't see that coming. And I put this on Mastodon. Someone said that today is not April 1st. You can't say stuff like this. I said, it was my feeling too. Why would you do that? But if you love Edge, you can put Edge on Linux. And maybe there's reasons to love Edge. To be fair, I haven't given Edge a try. Well, okay. I haven't used much of anything from Microsoft willingly in years, so maybe it got better when I wasn't looking, but no, okay, all right. Anyway, this is an interesting thing. I have about 6 or 8 browsers on all my machines because I just separate them. This one's logged into that stuff, this one's logged into that stuff. Firefox has added containers. So you can have this browser logged into this stuff, this browser logged into this stuff, this browser configured to go through a proxy for web app pen testing and so on, which is a pretty good idea, better than profiles. There's a new feature, multi-account containers, so you can have multiple settings of your browsers. And this might be good. This reminds me of the security product Cubes from Joanna Bruczkowska, who is the most amazing rootkit researcher from Poland. And Cubes is a Linux distribution where you have like 4 virtual machines running with color-coded, and you use like the red one to do your banking and the blue one to do your social networking and so on. And that way, even if you get hacked in one, it can't get to the others. And this seems like a version of the same thing. And so there's a privacy sandbox here. This is something I heard about. I heard about months ago Google was going to do this. And I think it's a pretty good idea, although it depends on how they implement it. The current implementation of ad tracking is Google knows everything about you. They know your name, your age, your email, your browser history, probably all kinds of stuff. And they don't really need to know all that. And in fact, knowing all that is a burden and a privacy exposure and everything. So what they're doing is they're implementing a system that just gives Google a little bit of information about you, like your age and what your interests are, so they can target ads, but not just everything about you, which does seem like the right way to go. I mean, the old ad tracking model, which Google got when they bought DoubleClick, was to put cookies that were unique to everybody on your machine, so they totally identify you and they know everything you do everywhere. And that was how the original ad tracking worked, but that has the side effect that they know far more than they need to know, like all the physical locations you go to and everything, and if they lose that data, now they've exposed all your privacy. They don't really need to know all that. All they really need to know is like 10 facts about you to target an ad. And in fact, other people have been saying they're just going to abandon targeted ads entirely and go back to the way it was before targeted ads, where if they have a magazine about horses, they advertise horses. And a magazine about cars, they advertise cars. They just take from the content a clue about what you're interested in and advertise that. They don't need to know anything about you. And that's where you reach the interesting business decision of how valuable is targeted ads anyway. Do you really need to target ads? How much do you precisely have to target them to make money? And so anyway, I think it's a positive step forward, but of course I'm sure there are details in how they implement it. And this I was very interested to see. If you take the malware analysis course, we talk about SSDT hooking. SSDT hooking is how rootkits work, and it's also how security products works, like firewalls and antivirus, up until about Windows Vista. SSDT is the service set descriptor table, and it is the master lookup table for all the Windows functions. And you can change the address in the SSDT, for example, for the file open function. And now, every time you open a file, instead of going to the Microsoft's file open function, it will go to some other file open function. And this is what an antivirus would do. Before you open a file, go to the antivirus and scan it, and don't really open it unless it passes that test. And this is how a lot of things worked. That was the old-fashioned way. This is called hooking. It's a way it's also how rootkits work. They would subvert the fundamental operation of the operating system to do something malicious. It can be used for good or evil, but it's out of date, and Microsoft no longer allows it in modern versions of Windows, and this explains modern techniques that do the same thing, IRP hooking and APC and create thread hooking, which we talk about briefly. And so anyway, I'm very interested in this because my malware analysis class, we used to write rootkits, and then I quit because the old technique didn't work, and if I can understand this, I can write a new project where you write rootkits using the new ones. Anyway, it's important in the world of Windows internals to understand these things, and this looks like a good explanation of it. So this, at first, I thought was silly. I mean, we've had quantum random number generations forever, but this one is very good. But apparently the old quantum, now I thought Johnson noise was a quantum random number generator. Apparently not. That's the standard way you do it. You just have a current flowing through a resistor, and because of the thermal motion of the atoms, it varies, and you just magnify the noise, and you get random numbers. But apparently those are not quantum random numbers. They're thermal noise. So quantum random numbers would be more random, and the way they've done it before is with lasers, but this guy figured out how to do it with LEDs, so that would make it really cheap to make hardware random number generators everywhere. That's why it would revolutionize things. You could have quantum hardware random numbers for cheap built into your computer. And so he's probably right. That would really improve things. If you've taken the cryptography course, we've already had a lecture about this. A whole lot of security flaws are caused by not having good enough random numbers. If you really need to have unpredictable random numbers to encrypt things, and there have been a bunch of examples. For example, the internet, HTTPS certificates. There was a research project about 10 years ago from a researcher in Canada where they downloaded all the HTTPS certificates on the internet and checked them, and 1 in 1,000 of them are using identical keys. Just because you have a hardware like a firewall, you boot it up, there are this many clock cycles, it reaches the point, now it creates a so-called random number. Well, the only thing it has to make that random number is like the number of clock cycles and the time of day and stuff, and so there's a chance it'll have the same random number as another firewall you turn on at the same time, and that's not a zero chance. In fact, it turns out that's pretty likely. Identical hardware running the same code, there's no actual source of randomness anywhere, so adding one of these to the device would make it much better, where you really have something completely random to make the random numbers you need to do encryption. I saw this when I made a Java-based server to use for a hacking contest, and I caught it was broken, but one day I finally gave up and walked away, and when I came back it was working. It took 45 minutes to boot up. And this was a known flaw in Tomcat Java-based applications because it needs to have a random number to seed the key. And if you just have a headless server, there's no keyboard or anything, and so it takes a really long time to make the random numbers. You have to install a special application called Haveged, Haveged, which makes it boot up in 1 minute because it creates a steady supply of random numbers. And I said, that sounds bogus, that can't be real, but it's real. And again, one of these things would solve that problem in a much better way, because I imagine Haveged is not really making truly random numbers. It's making the thing, it's creating pseudo-random numbers. It doesn't have any actual quantum randomness, so it's probably the numbers it's putting out are not entirely random either. But at least it made the thing boot up. And this is amazing. If you have a Linux-based encrypted hard drive using the Trusted Platform module, the way the Microsoft encryption does, it turns out that all you have to do to break in is plug in a USB dongle and run a script that will press enter really, really fast. Now, if you hold down the enter key, it'll do 10 enters per second, but you can program it to do 100 enters per second. And if you do, when you boot it up, there are 2 passwords that go by. You know, if you have a Windows machine, it'll say enter the passphrase for the disk. So it asks you for the password to decrypt the disk, then it's going to ask you for login password. And when you enter the password, if you put in too many wrong guesses, it will sort of exit the login routine and default to a root prompt. So just a bunch of enters will overflow the limited number of guesses here, and then you get a root prompt before the decryption, and from there you can just order the decryption, again, without putting in the key. So it's bloody awesome. Another amazingly simple trick that gets in. So anyway, let me stop the news.